Hey Bobcats, this is Mrs. Kelly. We are going to be starting a new unit to prepare for some algebra, our algebra units. This is our equations unit. We're going to start with some one-steps. A solution is a value that when substituted in an equation in place of a variable makes the equation true. So here, what I want you to do is I want you to understand the word inverse. Inverse is a fancy word for the opposite. Okay, so if I said, what's the opposite of addition, you would say subtraction. And if I said, what's the opposite of subtraction, you would say addition. Okay, what's the opposite of multiplication? That would be division. And what's the inverse of division? That would be multiplication. Okay? So when we talk about solving equations, we're going to take a look at PEMDAS and how it connects. Normally, right, you learn PEMDAS, and that's please excuse my dear Aunt Sally, where we start with parentheses, move to exponents, we multiply and divide, moving from left to right, and then we add and subtract, moving from left to right. So we normally go this way, right? We start at the top and we work our way down. When we're solving equations, we're going to start down here and work backwards, okay? So what's the first thing we'll start with? Adding and subtracting, okay? It's kind of giving you a little back information there. What I like to do is I like to draw a line down the side of my equation sign. Okay, this helps me understand the balance. So I always ask my students, what is the goal? And I like them to tell me, isolate the variable. And we all know a variable, right? Here, P. The variable stands for some unknown number. You might be trying to guess that number right now, kind of guessing and checking. But these equations are going to get harder. So we're not going to try to do them in our head. We're going to follow our steps. So I'm going to ask you, what's the goal? Right now you should be saying to isolate the variable. Okay? How do you do that? You do that through the inverse operation. And remember, the inverse is a fancy way of saying the opposite. Okay, so let's get starting with step one. What's your goal? Isolate the variable. How do you do it? The inverse operation. So I'm going to start on the left side because it has my variable. What's the inverse, the opposite of adding 5? Well, that would be to subtract 5. When we say a positive 5, take away 5, that cancels. We call that a zero pair. But what I do to the left side, I must come do to the right side. So here, I'm just going to write the word balance, right? So what you do to one side of the equation, you have to go do to the other, and vice versa. Okay, so I took away 5 here, so I must take away 5 here. This is canceled out, so this gives me P, and I'm going to bring that equal sign down. Now we're not going to get confused with these integers, okay? Some of you might be thinking the answer is 5. The answer is not 5. So I'm opening up a new calculator page. And what I'm going to do is I'm going to type it like I see it. So I'm typing in negative 10 minus 5. And see how I'm getting that negative 15? So I know my answer is negative 15. Now here's how I go check myself. How do I know if I'm right? So this P, what did we solve and say P was? We said it was negative 15. So I'm going to rewrite the original problem. Okay? For p, I'm going to plug in negative 15 plus 5 equals negative 10. So is this a true statement? Now there's a couple different ways you can plug it in here. You can say, all right, negative 15, type it like I see it, negative 15 plus 5. See how it gives you the negative 10? This is also kind of cool. You can say negative 15 plus 5 equals negative 10. See how it gives you that true statement? Pretty cool. Okay, so I know my answer is negative 15, and this was just me checking my work. Now, some of you might have gone, Miss Kelly, I knew the whole time the answer was negative 15 because I could see that. That's cool, but remember, we're going to harder places, right? I doubt you can do number 8 in your head. Maybe you can, okay? But they're going to get even harder than number 8, okay? So let's move right along to number 2. I'm going to get you started by drawing that line. And I'm going to say, what's your goal? I'd like you to pause, and I'd like you to try number 2. You're pausing the video. I'm going to keep going, and you're going to check your answer and hit play, okay? So my goal is to isolate the variable. All right, the variable's on the right side of the equation this time. So I'll be starting on that side. And I'm going to say, how do you isolate that variable? And you're going to say the inverse operation. Well, what's the inverse of taking 2.6 away? That would be to add 2.6. Well, now these cancel each other out. But what I do to one side, I do to the other. That's this idea of balance. So I say plus 2.6. So I know it's going to be R equals. So I'm going to type it like I see it. So negative 7.5 plus 2.6. I'm getting negative 4.9. Go ahead and box my answer in. Now I'm going to go check. Okay? So let's rewrite it. We've got negative 7.5 equals R minus 2.6. And we're going to say the R was negative. So R negative 4.9 minus 2.6. So see how I just plugged in there? And so I'm going to say negative 7.5 equals negative 4.9 minus 2.6. True statement. So I know I'm correct. Okay? I hope you can see that true there. All right, moving right along. Looking at number 3. I'm going to draw my line. I'm going to ask myself, what is the goal? The goal is to isolate the variable. How do I do that? This is tricky right here. All right, we're going to look at the operation or the sign right in front of the number here. It's negative. What's the inverse of a negative 34? That would be a positive 34. What I do to one side, I do to the other. I'm going to bring down my M. It all equals, and I'm going to type it like I see it. So negative 21 plus 34, that is 13. Now what I'm going to do is I'm going to rewrite it, and instead of writing M, I'm going to write 13 plus negative 34 equals negative 21. So I'll type it like I see it. 13 plus a negative 34 equals negative 21. That is a true statement. So I know my answer is correct. Okay, moving right along. Let's draw a line here. And I'm going to tell you, all right here. I think in 7th grade, it's keep, change, flip. Okay, pulling from that 7th grade lesson that you should have heard last year. What I tell my students, like a more algebraic way, anytime you have a subtraction and a negative here, what's really going on is you're multiplying by a -1. But keep, change, flip works as well, right? When they're backed up to each other, what happens is they both become positive. So really what I have here is r plus 8 equals -14. So we're going to start from here, and I'd like you to finish that out. So you're going to pause, get your answer. I'm going to keep going. So the goal is to isolate the variable. How do you do that? The inverse operation. -8, -8. Sometimes I write it horizontally instead of writing it vertically. And that kind of helps me sometimes when I see a whole bunch of negatives, right? So r equals, and I will type it like I see it. So I'm going to say -14 minus 8 is -22. Now I'm going to go in and I'm going to plug that -22 in. -22 plus 8 equals -14. Oops. Equals, so -22 plus 8 equals -14. That is a true statement. Okay. I'm going to move right along. Make sure you're pausing. If I'm moving too fast, please pause. And you can take those notes, okay, if you're not getting them. All right, you'll notice now we have moved on, okay? So we were doing the addition and subtraction. Now we're going to talk about the multiplying and dividing, okay? That's the next in our PEMDAS when we go backwards. So here, -5 times t equals 60. They don't write that time sign there. You have to know that, okay? Miss Lucky and I don't write that either. Neither does Miss Colvin. We write it just like this. So I'm going to ask you, what's the goal? And you're going to say to isolate the variable. And I'm going to say, how do you do that? And you're going to say inverse operation. So what's the inverse of multiplying? The inverse is to divide. And we're going to write it more high school. I think sometimes students in the past do this. They do like a divide by -5. This is very like middle school, junior high. We really shouldn't do that. I know we're junior high, but Miss Lecky and Miss Colvin and I, we're really trying to push you to that Dawson level. So we're not going to write the dividing sign like that. We're going to draw a fraction bar, because that's the same thing, and we're going to divide by -5. Well, use this resource if you get confused, okay? We're going to say, give it a second while it comes on. We're going to say -5 divided by, and what I'm going to do so you can kind of see it is I'm going to put that negative next to that 5, because that's how it looks on your paper, right? -5 divided by -5. Do you see how that equals 1? So these cancel out, and you're only left with 1t. We've isolated the variable. Now remember balance. What I do to the left side, I go do to the right side. See how I divided by -5 on the left? I divide by -5 on the right. So 60 divided by -5. And that gives me -12. So now I'm going to go plug in, because I want the validation to know that I'm correct. So I'll say -5 times t. So instead of writing t, I'll write times -12 equals 60. So -5 times -12 equals a positive 60. That is a true statement. Okay? Moving right along, we'll go ahead and go on to number 6. Number 6 is designed just like number 5. I'd like you to pause and give it a go. and then you can unpause me and see if you got the right answer. What's your goal? Hopefully you're saying isolate the variable. I'm going to ask you, how do you do that? You're going to say inverse operation. What's the inverse of multiplying by 2.3? That is to divide by 2.3. So those will cancel out. So n equals, and we'll say 115 divided by 2.3, and I get 50. So now I'm going to go plug in 2.3 times n. 2.3 times 50 equals 115. 2.3 times 50 equals 115. That is a true statement. All right. Okay, number 7. Hopefully you're going, oh, this looks a little different, and it looks like the r is divided by -4. So I'm going to ask you, what's your goal? And you're going to say, my goal is to isolate the variable. Okay, I'm just rewriting my problem here to give me a little bit more room. Okay, so what's the inverse of dividing by -4? The inverse would be to multiply, right, by -4. Now, no one ever explained to me what was going on over here. They just kind of told me to accept it. So what I want you to know right now is what I'm telling you is what's going on. If it confuses you, forget I said it, okay? When multiplying fractions, you know you've got them. It's top times top and bottom times bottom, right? So this would be -4r, -4 times r, and then 1 times -4. Do you see how that looks an awful lot like that? Right? So this is what's going on behind the scenes, but when Miss Lucky and I teach this in class, we don't go that far in detail. We just say, hey, what I want you to know is that these cancel out, right? And you're just left with that r. Okay? So the inverse of dividing by -4, excuse me, is to multiply by -4, and those cancel out, right? Just like here when we said -4 over -4 is going to give you that 1. We just don't write that 1 there. All right? What I do to one side, right, and we times by a -4. The only reason I wrote a 1 under it was because we were in fraction form over here, right? So don't get confused by that, okay? If this confused you, what I want you to know is that you just say, hey, I'm going to multiply by that -4, and they cross out, so I'm left with that r. So we multiplied by that -4. We multiplied by that -4, so we'll do it again over here. 15 times -4, that should be -60, but I'd like to check myself. There it is. And now, I'm going to go check the whole problem. So I'm going back up to my original. For r, I'm going to write -60 divided by -4. Does that equal 15? So I say control divide, -60 over -4. See how that gives you 15? If you wanted to, and you wanted to write the equation to give you that true, you could do that as well. All right, so your answer is 60. Okay, over here, 2b divided by 3 equals 12. All right, so what I kind of did here, right, kind of just did that 2b is up there. I love how Miss Lucky teaches this, okay? So I'm going to teach it like her. You got two things going on here. So technically this is a 2-step. It's a little bit harder. So what we're going to do is we're going to get rid of the denominator first. Okay, how do I get rid of, and I'm jumping ahead of myself a little bit. Remind me, what's the goal? The goal is to isolate the variable. So we're going to multiply. Why are we multiplying? Because this is dividing by 3. So how do we get rid of dividing by 3? We multiply by 3. See how those go away? Just like over here. If I multiply by 3 on this side, I multiply by 3 on this side. So I'm going to say 12 times 3 is 36, and I'm going to bring down that 2b. Now I'm going to ask you, hey, so what's the goal to isolate the variable? What's the inverse of multiplying by 2? That would be to divide by 2. So b equals, and 36 divided by 2 is 18. So now we're left to go check. And we'll say 2/3, right? And that's 2/3 times b. So times 18 equals 12. So 2/3 times 18 equals 12. That's true. All right, y'all take care, stay safe, and be kind.